this subject, which is BELC 3543 microprocessor. So basically, this problem-based learning PBL, our team choose the topic solid moisture driven irrigation system. So let's we have a four member, which is me, Muhammad Hisyamuddin, MUKIMIN, and another member, MARAN, and AIMAN. So definition and scope, which is international irrigation method, are still weapon used in a small farm and home garden. These systems are used to control manually and leverage in the real time. So they often lead to overripe watering or underwatering. So advanced irrigation system that is but the high cost, complex and not suitable for every situation. So this project we are aiming to solve this problem with low cost efficient irrigation system. The system used by microprocessor technology and respond to soil moisture level. So about problem statement, what is often used initially in irrigation? Traditional system use time or manual control, not actual solid moisture. This wastes water and with harm crops. A better way is to automate watering based on solid moisture. The microprocessor can read moisture level and control water level. Watering happen only when needed. So have a sensor and the water pump in this project to read moisture water, moisture of the soil. So this project we are assembling the system use the Motorola 8K microprocessor, and in the simulator we are use LED and fish to show water usage and soil condition.
Assalamualaikum to everyone. My name is NAZMI HAZIQ bin Muhammad Aziz. My matrix number is B1123100092. Okay, now I will present about objective. Okay, first, to design an automatic irrigation system that function based on soil moisture detection. Second, to implement the control logic using the Motorola 68K microprocessor within the IDE 68K programming environment. Okay, the third one is to simulate and validate the system operation using easy 68K software, ensuring that the logic performs as intended and responds correctly to simulate input. Okay, next, project scope. The project scope is a simulation rather than a real hardware implementation. In this setup, switches are used to represent soil moisture sensor, while LEDs indicate whether watering is active or not, or another word is on or off. Okay, a 7-segment display is used to show which crop is currently being watered. The program controlling the system is written in assembly language using the IDE 68K development environment. Additionally, an LED serves as a warning signal to indicate when the soil is already moist, helping to prevent unnecessary watering. The primary goal of this simulation is to demonstrate the functionality and concept of the system using a microprocessor in control, simulate environment. Okay, that's all from me. I will pass to the next presenter.
For my part, I will present about proposed solution and simulation. The system simulates a smart irrigation setup using the Motorola 68K microprocessor. LEDs show the soil moisture status for different crops. If moisture is low, the LED will light up. The program turns on a simulated water pump automatically for 3 seconds to pump the water. A 7-segment display shows a number for the crop being watered. For example, sawi, bayam, chili or kailan. After all crops are watered, the system resets and get ready for the next cycle mode. So we proceed to the simulation. As you can see, this is our simulation. We use 3 peripheral, which is a 7-segment display. Is show as the crops that you water. The LED as indicator to show the moisture of the soil. And the switch will act as a system to start and end. Now let's run the simulation first. As you can see, the LED 0 is turned on to show that the system is ready to begin. Switch 0 is at the system want to start or end. When I press the switch 0, the system will start begin. As you can see, the LED 1 is turned on to show that the soil is not moisture. So water pump is already pump the water for 3 seconds. When the LED is turned off, it shows the soil is already moisture. The 7-segment display is shown as sawi, bayam, chili and kailan. One for sawi, right now is bayam. Now the water pump is pump the water for 3 seconds for the bayam. And the system will repeat it until it will complete the cycle. And now the 7 segment display shows 3, which is the chili, and the next is 4, which is kailan. And this system will complete until it will start again to check the soil is moisture or not. Start from sawi, then bayam, chili, and kailan. It will be repeated until the switch 0 is turned off. That's all from me. Thank you.
In conclusion, this problem-based learning PBL project focuses on designing a smart irrigation system that automatically responds to real-time soil moisture levels. The system activates a water pump when the soil is dry and turns it off once the desired moisture level is reached. Helping to avoid overwatering and underwatering, it also reduces the need for manual monitoring, making plant care easier and more efficient, especially for users managing multiple plants. In addition to saving time and water, the system supports healthier plant growth. This project also highlights how microprocessor knowledge and the use of IDE 68K can be applied to solve real-world problems, offering a simple yet effective solution for sustainable agriculture. Thank you.